A very lovely hello to all my class 10th champions, to all board warriors. So my dear champion, in today's video, I am going to teach you entire real numbers, complete real numbers, just in 30 to 35 minutes. Yes, my dear champion, just in 35 minutes. So basically, this is going to be one short video, just to give you a quick revision, short revision, my dear champion, so you all can revise your complete real numbers just in 30 minutes. So let's begin this video without wasting a moment. So if we talk about in this chapter, what topics that we are going to study here. So our goal is introduction to number system. What is number system? How many types of numbers are there? So I'll be giving you everything, clarity. Fundamental Theorem of Arithmetic, in short, it is also called FTA, Fundamental Theorem of Arithmetic, HCF and LCM, and relationship between them. So how to find out the HCF and LCM between two numbers? So basically by using prime factorization method, I'll be teaching you everything here in this video. And word problem based on HCF and LCM, the question generally comes up in your test, in your exam, even in board exam from this particular portion, and proof of irrationality. How number can be proved as irrational number by the way. And this is one of the most important topic as per if I talk about board examination point of view. So this one question confirm comes up from this particular point, that is proof of irrationality. So let's begin. So now, what is number system? So basically, number system, what is number system? So my dear champion, in mathematics, there are variety of numbers. There are different types of numbers. So here in this chapter, we are talking about real numbers. Complex number is other part. You will be studying complex number in standard higher classes. That will be in class 11th or PUC first year. Here in class 10th, you are studying here real numbers only. So if we talk about real numbers, so what is real numbers? So real numbers, basically my champion, it is the set of all rational and irrational numbers that can be represented on number line. Are you getting my point? The set of all rational and irrational numbers that can be represented on number line. I hope you must have studied about rational and irrational number, the number that can be arranged, that can be written in the form of P by Q, where Q should not be equal to 0 is a rational number, and the number that cannot be represented in P by Q form, that is called irrational number basically. So let's talk about real number. So real number represented by capital R, this is the symbolic representation, and in real number both comes up. Can you see here? Rational number and irrational number both comes up, the combination of both. Now if I talk about rational number, so now again rational number is categorized into two types, into two category, non-integer rational numbers and integer, both comes up in this category. Rational number, it is represented by capital Q. Okay, integer is represented at capital G. Do you know integer? The combination of all negative integer, negative and positive value. The combination of negative and 0 and positive value, positive numbers is called integer. Now integer is again distributed into two branches. One is negative numbers and other is positive numbers, and the whole number, all whole numbers are positive numbers. Just have patience, I'll be giving you the information about whole number also. So my dear champion, whole number is basically 0, 1, 2, 3 and so on. It means that whole number starts from 0 and so on. So whole number consists of 0 and natural number. Natural number, do you know? 1, 2, 3, 4 and so on. So the combination of 1, 2, 3 positive value and this 0, that will combinedly give you whole number. So natural number comes up under whole number. Are you getting my point? Because natural number starts from 1 and whole number is combination of 0 from 1 to 3. It means 1 to 3 is also there, right? Now, these are the negative numbers. I mean minus 10, minus 9, minus 8, minus 6. These are the, but negative and positive, both combined comes up integer. So this is called integer. So this is all about, my dear champion, number system. Now one very important thing here. Let me tell you one very important thing. So there are few categories also. Now first, if we talk about what are prime numbers. So champion, please focus here, prime numbers. So prime numbers are all those numbers. Prime numbers are all those numbers which are having only two factors, 1 and itself. I mean, if I ask you one question from you, My dear champion, I'm having 7 number here. Now I'm asking you, by which numbers 7 can be divided? So how many factors 7 has? So 7 can be divided by 1 itself and 7 itself. 1 and itself. There are only 2 factors. So 7 can be divided by only 1 and 7 itself. So 7 is a prime number. Are you getting my point? Prime numbers are all those numbers which are having only 2 factors. Only 2 factors. Come on, champions. Only 2 factors. Only 2 factors, right, my champion? 1 and itself. Lot of examples are there. So many examples are there. If I talk about 2, 2 is the smallest prime number because 2 is having prime factors 1 and 2 itself. 2 can be divided by 1 and 2. Now the second prime number is 3 because 3 is also having only 2 prime factors. 3 can be divided by 1 and 3. Now after 3, 5 comes up. 6 will not be there. 4 will not be there because 4 can be divided by 1, it can be divided by 2, and it can be divided by 4. So one extra factor is there. So 4 is not a prime number. Now 4 is called composite number. Such numbers are called composite numbers. So the numbers which are having more than 2 factors, 1 will be there, number itself will be there, and 1 more, 2 more, 3 more extra factors will be there. Such numbers are called composite numbers, and these numbers, etc., these numbers are called prime numbers. So this is first prime numbers, and the second comes up is composite number. So my dear champion, please focus here. Composite numbers. So composite numbers are all those numbers which are having more than 2 factors. Simple, more than 2 factors. More than, my champion, more than 2 factors. For example, if I ask you 4, so 4 can be divided by, come on, 4 can be divided by 1, 4 can be divided by 2, and 4 can be divided by 4 itself. So how many factors? 3 factors. So that is the reason why 4 has become composite numbers. So 4 is the smallest composite number. 2 is the smallest prime number. Please keep it in mind. Which is the first prime number? 2 is the first prime number. Which is the first composite number? 4 is the first composite number. Are you getting my point? And after 4, which number will be the composite number? 5 will not be there. 6 will be there. Because 6 can be divided by 1, 6 can be divided by 2, 6 can be divided by 3, 6 can be divided by 6 also. Oh my God, 4 factors are there. So how many factors are there, champion? 4 factors are there. 4 factors are there. Right? So 6 is also a composite number. I hope you are getting my point. So the difference between prime number and composite number now clear. Moving to next point. Look at the question. Are the following statements are true or false? So we have to reply the answer of these 3 questions in yes or no form, true or false, and we have to justify also our answer. Right? The first question is, every whole number is a natural number? No. No, no, no. Because my dear champion, if we look at here, so whole number is what? 0, 1, 2, 3, 4 and so on. Natural number is what? It starts from 1, 2, 3, 4 and so on. Can you see here? And if we talk about integer is also there. So integer means what, my dear? Minus 4, minus 3, minus 2, 1, minus 1, 0, 1, 2 and so on. So the first question is, every whole number is a natural number? No. In whole number 0 also comes up. But in natural number 0 is excluded. 0 is not there. 0 is excluded. So every whole number will not be natural number. But every natural number will be the whole number, because natural number starts from 1, 2, 3, 4, right? And the whole number starts from 0, 1, 2, 3, 4. So 1, 2, 3, 4 counting is also there. So this is absolutely false. This is false. We can write here also false. Second is, every integer is a rational number. Of course, champion, because minus 4 can be written as minus 4 by 1. 0 can also be written as 0 by 6. So every integer is a rational number. This is absolutely correct. This is true. Every rational number is an integer, not at all. Let me give you one example. So let me take one example, 10 by 3. So my dear champion, 10 by 3 is rational or not? Answer is yes, this is a rational number. Why? Because it is written in P by Q form, where Q is not equal to 0. But if we look at the decimal expansion, this is equal to 3.33333333. 3.3. Decimal number, this is decimal form, and decimal, this is a decimal form. And do you know, my dear champion, in integer no decimal forms is there. They all are whole, but negative is 0, negative is there, positive is there, and 0 is there, but all are whole form. There is no any decimal number. So every rational number is not an integer. So this is absolutely false. Every rational number is an integer. This is absolutely wrong. I hope you have understood. Okay, now first question. Explain why this number and this number are composite number. What is the identity of a composite number? How you can say the number is composite or not? The number should have more than 2 factors. So let's check it once. So the first is, my dear champion, 5 into 11 into 13 plus 13. So can we take 13 as common here? So this will become 5 into 11 plus 1. So this will be 13 into 11 into 5, 55 plus this will be 56. And if we can expand this 46, this is 56. So this will be 2 to ja, 4 to ja, 8, 7 ja, 56. So it can be written as 2 cube into 7 into 13 to power 1. Oh my God, what this expansion is showing? This expansion shows that this whole number can be divided by 3, can be 2, can be divided by 7, can be divided by 13, and can also be divided by this whole number, whatever the number will be coming there. Right, my dear champion? So how many factors this number has? How many factors this number has? Lot of, 1, 2, 3, and number itself 4 factors. So of course this is composite number. This is composite number, because we are getting here more than 2 factors. Now similarly, if we talk about here the second number, this was A and this is the second number. Can you see here? Can we take 5 common? So by taking 5 common, we are having 6 into 4 into 3 into 2 into 1 plus 1. We have taken 5 as common because there is positive sign. This is positive sign, plus sign. So we can take 5 common. Now after solving this, can we please solve this? 6 4 ja, 24, 24 2 ja, 48, and 48 into 3 will be 48 into 3. Let's write it. 48 into 3 plus 1. Can we solve this? So 5 into 48, 8 3 are 24, and this is 144 plus 1. So we are having here, this is equal to 145. We can expand this. 145 can be expand as 5 2 ja 10 and 5 9 ja. So we are having 29. So this 145 can be written as 5 into 29. 5 into 29. And this expansion is saying that this whole number can be divided by 5, this whole number can be divided by 29, and this whole number can be divided by the value of this complete number also. So how many factors this number is having? 3 factors. 5 is the factor, 29 is the factor, and this whole number itself is a factor. So of course this will be composite number. I hope this is clear to you all, champion. So that the identity of a composite number is the number should have more than 2 factors. Please keep it in mind. The number should have more than 2 factors. Okay. Now moving to next point. Fundamental theorem of arithmetic, very important. Fundamental theorem of arithmetic. So this theorem says that every composite number can be expressed as the product of their prime, and this factorization is unique apart from other in order in which the prime factors occur. Very simple question. Let me give you an example. So my dear champion, if I am writing here 16, so 16 can also be written as 2 into 2 to the 4 to the 8 to the 16. So this will be 2 to power 4. So this is called prime factorization. If I talk about 80, so 80 can be written as 2 into 2 into 2 into 2 into 5. 2 into 2 into 2 into 2 to the 4 to the 8 to the 16. 16 5 to 80. So this can be written as 2 to power 4 into 5, and this expansion represents that this 80 can be divided by 2, can be divided by 5, and can be divided by 80 also. And if we combine this, so 2 to the 4 will also be the factor, 4 to the 8 will also be the factor, 8 to the 16 will also be the factor. Getting my point? So this is called, prime factorization method, which comes under fundamental theorem of arithmetic. We can write any number, any integer in the product of their prime factors, my dear champion, prime factors. So we have example, 480 can be written as 2 into 2 into 2 into 3 into 5. Listen. Look at here. So 420 can be written as 2 into 210. So it has become prime value. So we cannot do anything with this number. Now the expansion of this number will take place. So 210 can be written as 105 into 2. So again 2 is the prime number. Now 105 can be expanded 35 into 3. So 3 is now prime number. Now 35 can be written as 5 into 7. So as we got the prime number at the end, it means that the door has closed. Now we cannot expand these number anymore, right? So 420 can be written as 2 into 2 into 3 into 5 into 7, and this is called prime factorization, and it comes under fundamental theorem of arithmetic. I hope it is clear to you. How you guys can write? By taking the LCM. Always make sure to take the LCM. So 2, so this will come here. Now 2, this will come here. Now 3, which come here? 35 will come here. Now 5, 7 will come here. Now 7, 1 will come here. So 2 into 2 into 3 into 5 into 7. This is the prime factor. 2 into 2 into 3 into 5 into 7. So it can also be written as 2 square into 3 into 5 into 7. This is fundamental theorem of arithmetic. Okay, so there are few questions here. Express given numbers as the product of its prime factor. Very easy. So 140, we can take LCM here. So 140, we can write 140 in the product of its prime factor. So if we divide by 2, so this will come here 70. Now again 2, so 35. Now 5, so 7. Now 7, so 1. So 140 can be written as 2 into 2 into 5 into 7, which can also be written as 2 square into 5 into 7, and this is called product of prime factors for 140, right? Similarly, for 156 we can write here by taking 2, we can say 7 and 8 will come again by 2, so this will be 3 2 6, 3 9 ja. Now by taking 3, this will come 13, and 13 is itself a prime number. So 156 can be written as 2 into 2 into 3 into 13. This is the prime factor. Similarly, you guys can do this. Try this. So the unit digit is 5, so this will divide by 5 only. So kindly write this. Okay. Now, how we can find out the HCF and LCM? So HCF and LCM we can find out between any 2 number, 3 number, 4 number by using prime factorization method that we have done here. So this is called prime factorization method. So this method plays very important role into finding out the HCF and LCM between the integers. So we will be deriving the relationship between HCF and LCM also in question. So let's move. Okay, so the first point is, let's say there are 2 numbers, my champion. So the product of HCF between these 2 numbers, the HCF of these 2 numbers and the product of LCM of these 2 numbers is equal to the product of numbers itself. This is the relationship between HCF and LCM. Very important formula. Please keep it in mind. Please keep it in mind. The product of HCF and LCM of 2 integers is equal to the product of the integers itself. Okay. Look at the question number first. Find the HCF and LCM of 60, 84 and 108 using prime factorization method. So we have to prime factorize first. So 2 30 will go there, 2 15 will go there, 3 5 will go there, and 5 also. 60 can be written as 2 square. Why 2 square? Because 2 comes twice, into 3 into 5. This is the prime factor for 60. Now if we talk about 84, so 84 can be written as 2 into, so this will become 42. This is 21, this is 3, 7, and 7 is itself a prime number. So 84 can be written as again 2 square into 3 into 7, right? This is 7. Now if we talk about 108, so by taking LCM, this will be 54. Now this will be 27. Now by 3, this will be 9. By 3, this will be 3, and by 3, this will be 1. So 108 can be written as 2 times, so 2 square, 3 times, so 3 cube will be there. Now find out HCF. My dear champion, HCF is called highest common factor. Come on, highest common factor. So whenever you are finding out the HCF between the number, always take the least power. lowest power, smallest power. So if we take 2, so here 2 to power 2 is there, here 2 to power 2 is there, and here 2 to power 2. So in every prime factorization, 2 to power 2 is common, so we can write here 2 to power 2. Now let's take 3. So here 3 to power 1, here 3 to power 1, here 3 to power 3. So which power will come? Which power will be considered? 3 to power 1. Why? Because we are calculating here HCF. So for HCF, always make sure to take the lowest power. So we can take here 3. Now next new number is 5. Here 5 to power 5, but here no 5 is there. 5 is not present here. 5 is not present here. So imagine if 5 is not here, it means we can imagine 5 to power 0 would be there, and if here, this is not 5 not present here, so we can imagine 5 to power 0 would be there. Correct. So which is the lowest power? 5 to power 0. We have to take lowest power. So 5 to power 0 means 1. So we can write, otherwise you don't require to write, because 5 to power 0 is obviously 1. So HCF will be 4 into 3, this will be 12. 12 is the HCF of this number, and HCF is the number which can divide all these 3. 12 can divide this also, 12 can divide this also, and 12 can divide this also. So this is the lowest number, smallest number which can divide all these 3 numbers. This is called HCF, my dear champion. Now if we talk about LCM, so LCM is lowest common multiple, means we want to get that number which can be divided by these. HCF is the number which divides these, and LCM is the number which can be divided by these. So for LCM, we always take the highest power. So 2 to power 2, 2 to power 2 common, so 2 to power 2 will come. Right, if we talk 3, so 3 to power 1, 3 to power 1, 3 to power 3, which will come? 3 to power 3 will come, because we are finding out here LCM. Now if we talk about 5, 5 to power 1, 5 to power 0, 5 to power 0, so 5 to power 1 will come, because highest power. Why? We are finding out here LCM. Now can we please solve this? So 2 to 4 will be there, 3, 3, 3, 9, 27 will be there, and this is 5. So by multiplying this is 2, 7, 42, 5 into 4 will be 20, and 20 into 3 into 3 into 3 will be 27, and 27 2 ja 54, and one more 0 will be there. So this is the LCM for this number. It means that this number can be divided by this also, and this also. This is because this is the lowest common multiple. It means 540 will come in the table of 60 also, in the table of 84 also, and 108 in the table of 108 also. This is the LCM. Okay, there is solution given here also. You can get the solution here. Now, first question, next question. If 2 to power 2, 3 to power 3 into 5 to power 4 is the first number, and the second number here is, then what will be HCF? Come on, my dear. For HCF, what we take? We always take the lowest power. Lowest power of common factor. We always take the lowest power of common factor, and in LCM what we used to do, highest power. We always take the highest power of common factor. Highest power of common factor. Please keep it in mind. This is very important. So the solution will be look like this. So 2 to power 2 into 3 to power cube, and 5 to power 4, and the second number is 2 to power 3, 3 to power 2, and 5. So what will be the HCF? Do you know? Product of a smallest power of each common prime factor. Yes, so if we talk about 2 to power 2, so 2 to power 2 here also and here also, but here is 2 to power 3. So which is the smallest? 2 to power 2. That's why we are considering 2 to power 2. If we take 3, so 3 to power 3 is here, but here 3 to power 2. So which will be considered? 3 to power 2. Why? Because that is the lowest which is present in both. So 3 to power 2 is there, and 5 is common, 5 to power 4 and 5 to power 1. Which will be considered? 5 to power 1. So by solving this, we got the answer here 180, and 180 is the HCF. It means that 180 can divide this number and this number also. Moving to next. Find the LCM and HCF for 510 and 92 and verify the formula. This is the formula. We have to verify also by finding out the HCF and LCM. So 510 by doing the prime factorization method, this is the prime factor, and 92 can be written as 2 into 2 into 23. 2 into 4, 4 into 23 is 92. Now what will be the LCM? Find out the LCM. So for LCM, we always take the highest power. So 2 to power 2 and this is 2 to power 1. So which will be considered 2 to power 2. So here is 2 to power 2. Now 3 is here and 3 is not here. So if 3 is not here, we can consider 3 to power 0. So which will be considered 3 to power 1. So we are taking 3 here. Similarly 5 is here but 5 is not here. So we can imagine 5 to power 0 here. So which is the highest? 5. And here 17 is here but 17 is not here. So we can imagine 17 to power 0. Similarly 23 is here but 23 is not here. So we can imagine 23 to power 0. So which is present here but not here, we can imagine 2 power 3. So by multiplying all these highest power, we are getting 23,460 as LCM, and HCF will be lowest power. Lowest power. So 2 to power 2 and 2 to power 1 and 2 to power 2. So only 2 will be considered and nothing is common here. Now you can check. So HCF will be 2 here and LCM will be. Now if we multiply the number itself, we are getting here 46,920, and if we multiply this number and this number, it means HCF and LCM, we are getting same number. Hence verified the product of HCF and LCM is equal to the product of number themselves. Okay. Given that this number is both two numbers are there, A and B, and their HCF is 18, and again same number is there, we have to find out LCM. So we have formula, very important formula. So by using this formula, HCF into LCM is equal to the product of number itself. We got here LCM will be equal to 8,316. Now similarly, the LCM of two number is 9 times their HCF. It means that if we consider HCF as x, so what will be LCM? 9x, because LCM is the 9 times of HCF. So 9x plus x, HCF 9x plus x. The sum of LCM and HCF is equal to 500, which is equal to 500. So this will be 10x equals to 500. So x will be equal to, my dear champion, 50. And once you get 50, what will be HCF? This is HCF, which is x. So HCF will be equal to 50 answer. Moving to next. Solution is given here. Now, what problem based on HCF and LCM? So Ravi and Shikha drive around a circular sports field. Ravi takes 16 minutes. Okay, so there is a circular track and Ravi is starting from here, and Ravi takes 16 minutes to complete one circle. And from the same point Shikha is starting from the same points, and she takes 20 minutes to complete one circle. Okay, so the question is if both starts at the same point at the same time and go in the same direction, both are going in same direction, so after how much of time they again will be meeting with each other? So that is LCM. We want to calculate that number which is common for both, which can be divided by both number 16 and 20. It means that we want to calculate here LCM, and we know all how to find out LCM. So by taking the prime factorization value, the LCM will be 80. It means the answer will be 80 minutes. Okay, write the smallest number which can be divisible by this and this. Can you see? We want to find out the number which can be divisible by this and this. It means that we want to calculate here LCM. Why? Because we are looking forward to find out that number which can be divided by this, and that is only LCM. So we can find out LCM by doing the prime factorization of 306. 306, we are getting here number. By doing the prime factorization of 306, this is the prime factorization here, 3 into 2 into 3 into 17, and the prime factor of 657 is equal to 3 into 3 into 73. Now for LCM we take highest power. So here is 3, it means 3 square. We are considering 3 first, and here this is in this prime factorization 3 square. So 3 square will come. So 3 into 3 we are writing here. And if we talk about 2 is here but 2 is not here, so 2 to power 0 we can imagine. So which is the highest? 2. If we talk about 17 is here but 17 is not here, so 17 to power 0 we can write 17. Now 73 is here but 73 is not here, so we can consider 73 to power 0. So which is the highest in both prime factorization? So 2 into 3 square, 17 into 3, and by multiplying all these numbers we are getting this number. So this is that number which can be divided by this also. You guys can verify. Divide this number from this and divide this number from this. This number will be easily divisible by these two numbers. Okay, now the most important thing is proof of irrationality. Very important. See my dear champion, if I'm giving you root 5, we all know root 5 is irrational number, because root 5 root 5 cannot be represented in the form of p by q, right? But how we can prove this? This is the most important. So before moving to this topic, let me tell you one very important thing, my dear champion. Co-prime pairs. You should know co-prime pairs first to solve the question based on proof of irrationality. So my dear champion, what type of numbers are called co-prime pairs? Basically the numbers whose HCF is equal to 1. HCF means the highest common factor will be 1. You might be confused, I know. So let me clear your confusion. So example, let's imagine I have given you two numbers, 2 and 5. There are two numbers, 2 and 5. Now I'm asking you all, give me a number, bring a number which can divide both the numbers. Take a number, select a number which can divide both, means common factor. I am looking to find out the common factor. Common means, you know, the number which can divide both. A factor means the number which can divide. So I want to find out the common factor for this pair. There is no common factor except 1. 1 is the only number. 1 is the only number which can divide 2 also and which can divide 5 also. So 2 and 5, this is called co-prime pairs. Yeah, we can also say co-prime numbers. I hope you are getting my point. Co-prime numbers, clear? Is it clear to everyone? Now again, some more examples. If I ask you, find out the common factor for 11 and 17. 11 and 17. Is there any number which can divide these two? Which can divide these two, I'm asking, not only one. These two. So no, there is no any number which can divide both. Only one is there. HCF will be 1. So it means that if the HCF is 1, 1 is the only number which can divide 11 also and which can divide 17 also. So this 11 and 17, this pair is called co-prime pairs. Co-prime pairs, or we can also say co-prime numbers. So co-prime numbers always comes in pair form. I hope this is clear to you all. Okay, moving to prove that root 11 is an irrational number. My dear champion, this type of question is generally we solve by using contradiction method. This method is called contradiction method. Contradiction? Contradiction means when some error occurs, some error produces. That is called contradiction. So this is called contradiction method, or we can also say this is assumption method. This is assumption method also. So we are going to prove root 11 is an irrational number by assumption method. And what is mean by assumption method? So my dear champion, so here we will be supposing or assuming here root 11 as a rational number. So we are going to assume root 11 as a rational number. So let's assume root 11 is a rational number. So my dear champion, just imagine if you have assumed root 11 is a rational number. It implies that root 11 can be written as what, my dear champion? P by Q. Because if root 11 is a rational number, so the format must be P by Q form. Root 11 can be represented as P by Q form. And always make sure to mention here P and Q both are co-prime pairs. Please, my dear champion, don't forget to write this line, because otherwise your marks will be deducted in examination hall in exam if you forget to write this line. This is very important. P and Q are co-prime numbers. What does it mean by co-prime numbers? It means that P and Q both are having only one factor. It implies that only one factor. And which is that factor? Only one factor, and that is equal to, you all know that will be equal to 1. So 1 can divide P and Q. This is the assumption. P and Q both are co-prime numbers, so only one factor will be there. So HCF will be 1. Now if root 11 is P by Q is equal to P by, can we cross multiply this? So if we cross multiply, root 11Q will be equal to P, squaring both sides, squaring both sides, my dear champion, what will be the format? Root will remove here. So 11q square is equal to p square. Now can you see here? 11 is in multiplication form with q square. It means that if we bring this 11 this side, if we take this 11 this side, it means 11 will be divided to p square. So it means p will be divided by 11. So here p square is divided by 11. So we can write here p is also divided by 11. It shows that there is some contradiction occurred, because p and q both are co-prime pairs, so there will be no any factor other than 1. But here what we have proved, oh my god, p is divisible by 11. This is something wrong is going on. Okay, so let's assume now if p can be divided by 11, so p can also be written as 11c. I am taking some new term here, some new constant, which is c, because p can be divided by 11. Call this as first equation and call this as second equation. My dear, if p can be written as 11c, so we can put here p. So on putting second in first, what will be the format? On putting second in first, so 11 q square is equal to p square will be putting as p square will be replaced from 11c. So what will be the result here? So 11 q square and this 11 square will be 121c square. So 11 will cancel by 11. Oh, q square is equal to 11c square. Now 11 is the right hand side in multiplication form. It implies now 11 may come this side, 11 can come this side. Now q square is dividing by 11. So here q square is divided by 11. So q is divided by 11. Q is divided by 11. Oh my god, p is divided by 11, q is divided by 11. It is the contradiction. The contradiction has occurred because p and q both are co-prime pairs. Only one factor will be there. How this is coming here? If p and q both are co-prime number, how is it possible? So that there will be one more factor. So this is the contradiction. This shows contradiction. This shows contradiction in our assumption. This shows contradiction in our assumption. And what was our assumption? Our assumption was root 11 is a rational number. So this is not possible. Root 11 cannot be rational number. So it has to be irrational number. So this contradiction in our assumption, this shows contradiction in our assumption. So root 11 is an irrational number. I hope this question is clear to you all, champion, and this will give you sure shot of 5 marks in your exam. And this question confirm, mandatory, confirm comes up, definitely will be there in your exam. Okay, so this is the solution also given here. So whether we can take p by q, we can take p by q if we are assuming root 11 as a rational number. So we can write here p by q, and somewhere, sometime in other different book, people used to write here a by b, but no difference. You can take x, y also, whatever you can take, doesn't matter. If root 11 is rational number, so rational number means something by something. Okay, so few questions are here. Prove that 2 plus 5 root 3 is irrational number. Again, how we can prove it? By assuming it as suppose. So we have to suppose here, we will have to suppose here 2 plus 5 root 3, 2 plus 5 root 3, what my dear? Rational. And once you supposed this number as rational, so you have to write 2 plus root 5 is equal to a by 2, a by b, because a rational number can be written is in the form of a by b. Okay, so whenever some number is in the form of root and other number is there across that number, so always make sure to keep root function at one side and all those integers other side. Keep root function, root family at one side, and all other remaining thing will be other side. Okay, so root 3 is the right side, and by doing mathematical calculation, this is equal to a minus 2b by b, and a minus 2b by b, this whole is the format of rational number, but this root 3. So if this is rational number, so it has to be rational number, because both are equal to each other, which is not possible. So this is the contradiction. This is a rational number. This circle is a rational number, but root 3, so root 3 will have to be a rational number, which is not possible because root 3 is a rational number. So this is the contradiction. So how this contradiction occurred? Why this contradiction occurred? Because our assumption was wrong. We assumed that root 2 plus root 3 is a rational number, which is not true, which is definitely wrong, which is absolutely wrong. So 2 plus root 3 is an irrational number also. So thank you so much for watching the videos, my dear champion. So if you are having any kind of problem, any difficulty while doing NCERT question, NCERT problem, please do let us know. Comment in the video so that I can have a clarity, I can have a short idea what kind of problem and challenges that you guys are facing in doing the question after watching this video. Thank you so much for watching the video. Stay blessed and bye-bye.